We announced this about a week ago, and we are going to make it available to the general public probably right before Thanksgiving, if not right after. So just a couple things. So first of all, we are with 7.2, we are shipping HPC RPMs. So really what we're trying to do is we're trying to have a very easy process to install the product. We've heard from time and time again from our customers that we want things to just work and be a lot easier to do. So all you do is basically untar the basic RPMs, install your repos, and run yum install, and you can configure Torque and Moab. So that is a much easier process now. So the other thing that I'm really excited about this one, what we're doing is we are supporting Intel mics, Xeon Phi basically. If you just head straight back that way, you can see the Intel Xeon Phi PCI boards. We do have a demo over here that actually has real hardware behind Scott. So what I want to do is I want to kind of talk about how we approach this problem. So first of all, MIC stands for Many Integrated Cores. It's an architecture, not a product. And the first product that we are supporting using this architecture is Intel Xeon Phi. So they announced it yesterday, and we have a number of boards that we got in as a partner to develop against. So let me talk about what that looks like. So first of all, I wanted to highlight the similarities between GPUs and mics and how they're different after that. So the similarities is first of all they both connect through a PCIe interface, and it basically integrates directly into your HPC compute node module. So you have the NVIDIA Tesla S-Series, and then you have the C-Series as well as the Xeon Phi that fall into these two different categories, and then the Tesla M-Series here. So the differences is that the GPU, from our perspective, are these attributes. So first of all, it's purpose-built, right? So it's not a general purpose processor. It has very specific application applicability, and they're specialized, right? You don't run them on a general purpose OS. You have the CUDA libraries, and you can't run your normal programs. And it requires some significant HPC software modification for your applications. And one of our customers, one of the national labs, basically said it's going to take them 4 man-years to port one of their applications. Compare and contrast that to mic-based devices where it's x86 compatible, and it runs on your standard Linux OSs, and it can run normal programs. So basically, what we're seeing is that it requires very little modification. And the reason for this is because it's compiler-driven. So for those of you who don't know yet, and again, just head straight back, I went and confirmed the booth. It's the demo on the back side from here where they're demonstrating the Xeon Phi board and showing you different specs on it. But basically, Intel has provided a compiler that allows you to compile your program code into 2 binary program files. So there's a Xeon file for your main program and your serial code, and then there's a Xeon Phi file for your parallel code. So it generates 2 files, and what it does is from that you have your program execution, and the main program will call out to the parallel code on the Xeon Phi chip. So because it's compiled, it really allows you to have the compiler and the program execution take care of it for you, which is a brilliant architecture. So obviously, the anticipated benefits is it's going to be a lot less developer time, which is awesome because we like to get work done and we don't want to create more work for ourselves to get that work done. So just to kind of visualize what I verbally spoke to, you have the Xeon processor and the Xeon Phi processor within the same compute node. And basically when the program starts, it calls out to the parallel code. The parallel code comes back and just bounces back and forth, pinging each other. So really self-explanatory, but like I said, we have them set up over here if you want a more hands-on understanding. Okay, so how we've done this within the Moab product suite in the HPC Suite 7.2 and Torque 4.2 is basically it's set up for auto detection of the mic devices. So basically you define at configure time that you want to enable mics. Our RPMs that we provide that I just described have that built in by default, and it will check for the mic devices using Intel's APIs that they've provided to us. It reports them up to the Torque server, and then the Torque server reports them to Moab. So it's a very seamless integration, not a lot of configuration that has to be done, and you get the bang for your buck that you would expect from the optimization layer. So how it shows up then is basically you would do an M sub or a Q sub with your mic's keyword, just like you would with any other node attribute or that you would expect, like CPUs, etc. So we do treat it much like a first-class citizen attribute that you see with prox and mem. Using Moab's flexible GRES architecture, we can pull that into Moab very quickly. So you can see here that using your standard job submission syntax, either with a colon or with a comma, it will describe if you want mics on a per node basis or on a per job basis, which gives you that flexibility that you would expect from any of your attributes for job submission. And then Torque basically allocates those devices to the job as you would expect. So again, really, we try to make this as seamless and simple as possible, taking out any of the hurdles that you would expect from new hardware. You can also set it up manually in case there's problems. So if you go into your nodes file, your PBS nodes file, your Torque nodes file, excuse me, you just specify it mics equals, and away you go. But as you can see, there's the configure line enable -mics. Like I said, our RPMs provide that out of the box through Adaptive's the product suite RPMs. So I know it's difficult to read, so let me just speak to this. Here you see a PBS nodes output that has two nodes. They actually are represented over here as a Red Hat OS and a SLES OS. So we did test this on these two operating systems, with these two operating systems, to make sure that we worked out any Linux kernel kinks or anything like that may arise. And the things that you should be paying attention to is that we've added a new attribute to the PBS nodes output for the node. So you can see the mic underscore status, and in that you can actually see the individual processors that are on that PCIe card, and you can see the various attributes. So in our documentation, we've actually provided various metrics that the Xeon Phi boards provide back to Torque, so that we can actually bubble that up to Moab for scheduling decisions. So again, we can help our customers make those intelligent decisions as they use this new hardware. Similarly, if you look in the Moab output, you look at check node, and the check node output basically just trying to show that the mic status that I just described bubbles up through Moab's generic metrics attribute, and you can grab those for reporting purposes or for scheduling purposes. So again, very seamless. I think I just have a duplicate slide, excuse me. So another thing that we added is this single job dual domains support that we see with Cray systems. So the benefits of having a Cray are that Cray has really worked through a lot of the kinks of stripping out things that are not needed. With their CLE environments, that they are leadership class on a number of different things around I/O. With storage network, with the CPU and shared memory aspects. So, but there's often times where you have nodes that are external to a Cray system that are serving up data that are needed by a Cray. And so we've run into some scenarios with various customers where they want to basically have a simulation where you have the solid simulation, it's fairly static on the non-Cray nodes, and then you have the fluid simulation that's run within the Cray. Well, the problem that we run into this is that if you run multiple jobs, you can get out of sync, and it can fail very quickly, and there's a lot of manual overhead, and you don't get the automation and the scheduling benefits that you would expect from Adaptive's products. So with this, it allows you to have real-time feedback between the solid and the fluid simulations, and then obviously the solid simulation will feed the fluid will feed the solid, so you got this feedback loop like I just described. So I've already described what the problem is, the real-time simultaneous coupled simulation. And you have the fabric that I just described already. It's great for parallelizing the simulations. And then ALPS manages this job start and end. So the key reason why we've seen from our customers the need for this use case is this memory aspect, right? So on a per node memory basis, Crays don't have as much memory as you would see with non-Cray systems, and so we have this example where you have a terabyte of memory that you need to use for this solid simulation, which obviously must be part of a standard traditional HPC cluster. So you have the compute nodes that are on the Cray network, and then you have the external non-Cray node computes outside of the network. And so what we've done is basically through our product suite, we allow a user to submit a single job with a single script, with a single wall time. It gets sent to the server, PBS server. It detects that it's requesting the job in the different domains, separates the jobs in the different domains, and then sends the two jobs to the disparate moms. So under the covers, we are breaking it apart, but really we're trying to stitch those things together and keep them together so that things don't get out of sync and out of whack. So the Cray job is started using the PBS mom inside the Cray domain, and then the non-Cray job obviously starts in the external node. So how does this work, or what are some different restrictions before I get to how it works? So obviously the jobs have to have the same wall time limit, and the same job script has to run in the domain, both domains. Also, when it comes to job termination, you have the two subjobs as I described. So what happens with job termination rules? Well, basically, Torque handles them as a single job termination based on the exit code of the first subjob. So if you have a 0 exit code, obviously it'll allow the subjobs to complete unless they hit their wall time. If there's a non-zero exit code, it will basically just error out and cancel the other subjob. So like I described, some of the benefits is allows our users to be able to run these unique simulations in real time and utilize the resources that they have more effectively. And we break down those silos very well. So obviously, with the non-Cray compute nodes, you can get the higher capacity hardware that's available every few months, whereas with the Cray, it's typically a little bit more of a black box, and so you can tailor your hardware to your simulation needs. So what does it look like? Basically, the single job dual domain setup is in the nodes file. You just set a keyword of external on the nodes that are external to your system. And then what happens is that translates it into two keywords, the Cray compute and the external. That should say external, not externals, excuse me. Those are the two features. So if you're familiar with our product line, the concept of node features are used automatically so that you can set up your multi-domain very easily. So in this case, you can specify X amount of Cray compute nodes and Y number of external nodes. So those are the kind of those three things that I highlighted just to review. So we talked about RPMs, talked about Xeon Phi support or mic support in general. So when other mic architectures come out, we can support those easily. Talked about the single job dual domain, and then there's just other things that we've added. As always, if you're a user of our product, do look at the release notes because we do add a number of improvements and enhancements that aren't really large marketing type of initiatives that are maybe things that are useful for a couple of customers here and there. So please do look at this. So some different things that we added is we did address the GPU static allocation problems that we had in the past, so that you can either specify them on a node or a per job basis. We also have the services out of the box in the initd services are handled for SLES in a much more easy to use way. And we've broken out our docs to basically, there used to be a GPU chapter, now it's broken down into accelerators, and inside of that you have GPUs and mics, depending on what type of hardware you have. In addition to that, to my right and your left, we do have a product demo that we've done, this product integration with NICE, with their engine frame and cloud frame products and remote visualization, which is really cool. And also another thing that we've been asked for, by our customers is that with data dumps and data stores, customers want to be able to extract data in the ways that they want to create the reports that they want. So we've actually integrated Moab with MongoDB for jobs, nodes, and VMs for those that are using our enterprise or our cloud suites. So by default, HPC is not turned on for Mongo, but we do have customers that want to use it. And at this time, it is not available for SLES, so just a caveat there. And then just general things, just highlighting that we added some things in 4.1, 3 in Torque that will show up in 4.2, such as Max User Queuable, and there's other things like that. In addition, our allocation manager tool, we've changed some of the nomenclature to be just a little bit more easy to understand, to sync up with the Moab credentials. This is the change that are reflected. And then we've added a number of different QA initiatives around static code analysis, more regression tests, more automation, and so on. So if you have any questions, I'll step down. You can talk to me. You can talk to any one of the people in the blue shirts that say Adaptive about the product. We have data sheets over there by Sean, various demos to my left and my right. So if you're unfamiliar, please don't hesitate to reach out and ask. Thanks.